let me introduce our next speaker. Nick Handel is the CEO and co-founder at Transform, the first metrics store to make data accessible. The title of his talk, Metrics and Semantics, an Evolution in Data Consumption. Please put your hands together for Nick Handel.
Thanks. Hello. All right. Do I do anything to get that? There we go. All right. Nope, we're not going to reformat. All right. Thank you all so much for coming. All right, we are set up. Yeah, my name is Nick, and my talk is Semantics and Metrics, and just a little bit about me to get going. So my background is in pretty much data for the last 10 years. I started off at BlackRock. It was nice to see that they're a sponsor. And then went to Airbnb in 2014. It was this kind of golden age of data. I joined right before the release of Airflow, a bunch of other kind of internal tools, and was just lucky to work with a bunch of really great people. And that kind of started off my interest in semantics. And then I went to a micro-lender called Branch as their head of data, and then started working on Transform based off of some of the work that I did at Airbnb in end of 2019. A little bit of just fun stuff, trail running, skiing, nature. That's my dog, Huck. And I'm a big fan of cheese, as is he. And we do a lot of really fun stuff. The last talk, talked about training dogs, and Huck knows maybe 10 tricks, but he can run very, very long distances, which makes him a great companion for me. So, I kind of mentioned this background in working in semantics at Airbnb. I also worked on Airbnb's feature repository called Zipline, and then the broader kind of machine learning infrastructure tooling there called BigHead. And now I work on Metricflow, which is an open source metric store. And so the key to this talk is that this kind of core belief that I have that everyone is an analyst, or everyone is analytical, whether they're an analyst or not. And you can kind of tell by the way that people ask questions that whether they have data or whether they have context, what they are trying to get at is that they want to do analysis. And so these are just the kinds of questions that I fielded when I was a data scientist, and I see pretty commonly amongst our customers. And the primary role of an analyst is to take data and to kind of make it interact with the rest of the business, right? And so there are kind of two steps of that. One is to take the data and map it to the language, right? So as a business user, I'm going to ask for data, and I'm going to do that in kind of a variety of different ways. But oftentimes, I'm talking about metrics or dimensions. And then the next step is to do analysis, right? And so analysts are obviously really good at doing analysis, but everyone to some extent is capable of doing it and wants to do it. And the kind of initial process of pulling data can be pretty distracting and time-consuming for analysts. And it is pretty disempowering as a business user to want data and to not be able to access it. And so first I'm going to kind of just zoom out and take a more philosophical, make a more philosophical question, which is, what is data? And so if you think about what we have, well, we have reality, right? And reality is rich with data. If you look around you, if you think about data a lot, then you have a ton of experience in taking reality and turning it into tables and events and logs and everything that we use on a day-to-day basis. But when you do that, right, you can't record everything, right? Every grain of sand, every possible interaction that exists in the world. And so what you're doing is you're kind of granulating the world into a smaller subset, but something that's manageable for a data warehouse, right? And the final step is to take the data that we store and to try and recreate reality, right? Because you need to be able to look at the past and understand what happened. And so you form data narratives. And you kind of move from this crisp view of reality to this granulated view that is the data. And then you kind of try and enhance to get to a place where you can answer questions. And the semantic layer is particularly interested in that last arrow. How do you take data and map it back to reality, right? And there are best practices as you build a business where you kind of learn how to take the data that you're storing and turning it back into kind of an understanding of what happened in the past. And so then the dream would be is if you could, really understand the past and create it, recreate it more cleanly. So on a more practical level, we have a bunch of different tools, and we consume from data warehouses, right? And so you have storage and compute, and you have some kind of orchestration, and there are a bunch of different places where you want to consume data, right? And so you write logic in all of those different places to pull data out of the warehouse and to do analysis. And that's a lot of logic, right? And there's a lot of logic in those kind of downstream applications. And as much as you try to push that logic into the data warehouse to try and make it nice and consistent, it's just very, very hard to get everything into the data warehouse, and inevitably, you end up expressing some logic downstream. And as a business changes and grows, those maybe metrics are going to kind of lag in different places where you might have forgotten to update them. And so there's this kind of challenge around consistency. And the point of a semantic layer is to basically sit in between the data warehouse and the consumption tools and act as a single place to define all of this logic. And then exposing APIs allows you to kind of interact in all of these different places with that semantic layer. And this concept is not new. It's, I think that probably one of the first kind of references to semantic layers goes back to this patent in 1991 from business objects. And so I hope there are some people who have used business objects in some form. I have only done a lot of research on it, so you might know more than me about business objects, so I'm just going to leave it there. But this concept is not new. The idea of kind of trying to map data to language is something that has been of interest for a long, long time, but there have been a ton of evolutions in the way that we do data that have kind of changed the interactions that the semantic layer can have with both the data warehouse and those downstream consumption tools. And so now I'm going to do something very risky, and I'm going to try and give a demo. And so MetricFlow is an open source project. And so you can go check it out. This is something that we've been working on for about 2.5 years. We open sourced it about 4 or 5 months ago, and have just been kind of adding some stuff since. Lots of new features. You can always go look at GitHub issues where we kind of track all of the things that we're building into it. But the core of what this does is it builds SQL. And so I have gone in, I'm going to skip this first part because it's just set up and it's not very interesting. But I've pip installed MetricFlow. I've set up MetricFlow, which created this config file. I have made a copy of that config file so that you don't have my Snowflake credentials. And so you can see kind of roughly what this is. This is basically just a connection to a data warehouse. And then I've gone and I've run health checks, which basically just say, hey, can I connect to Snowflake? And I can connect to Snowflake. And with MetricFlow comes a very simple data model. And so the kind of idealized input into MetricFlow is a bunch of tables sitting in a data warehouse, but realistically, we've designed it so that you can put kind of whatever you want into there. You can put big, wide, denormalized tables. You can put narrow, normalized tables of a variety of different types. You can put dimensional, fact, SCD, really kind of whatever you want. And so these files are basically just YAML, and they explain where in the data warehouse I'm going. So in this case, I'm going for this transactions table. And they explain what are the kind of identifiers in this table. So I have a ID order, and that is a foreign key. What are the measures? So I would like to take the sum of transaction amount, or I would take the sum of one as transactions. And so these are kind of just definitions of metrics. And I have a few different tables here. I have a customer table and a countries table. And I'm going to kind of skip over this because you can look at these YAMLs if you want. But basically, it's just describing what's in the data warehouse. And we've done some cool work around inference where you can basically just point at a table and automatically generate these files, and then kind of manipulate them from there. So first things first, and this is a little bit hard because I'm working on not on the laptop screen. I already ran mfhelp, so this is kind of giving me all of the commands that I can run. I have this kind of CI/CD command, which allows me to validate the different configs. So what it's doing right now is it's actually building queries against the warehouse, making sure that all of those config files are referencing real tables, referencing real expressions, and that I can get back that data as I would like. And there's one more left, but it's the slowest one because it's actually building the metrics. And so this is kind of just running validations against the warehouse. It's going to return these results to me, and I might just cancel this. No, we're good. So great, I have no errors. Makes sense, I have a sample model. So then I can go and look at my metrics, and I have all of these metrics that I just defined in that file, transactions USD, etc., and a bunch of different dimensions that I can also construct those metrics to. So for example, in this transactions metric, I can join it to a variety of different dimensions. And this comes from that transactions table. But you can see here, I actually have some dimensions that come from other tables. And so behind the scenes, Metricflow is capable of rendering joins and then rendering, oh no, some fairly complicated logic to build. Do I have a USB problem? Capable of rendering some fairly complicated logic to build complicated metrics. So things like cumulative metrics, or one of the ones that we have in the works is conversion metrics, where you actually need to join two event tables and do some fairly complicated stuff. And so I can then take these metrics and dimensions. So for example, here I'm going to ask for the transactions metric by metric time. Metric time is this kind of universal reference to like the primary timestamp of a metric. And this is going to return some data to me, and that's really great. There is data under the hood here, but I actually want to see the SQL. I want to understand what's happening. And so I can tell Metricflow to explain to me what's happening. And what it's going to do is it's going to show me a bunch of complicated stuff of kind of like what it's going out and building. And then it's going to show me the rendered SQL that it can build against the warehouse in order to resolve this metric. This is a very simple metric, and so it doesn't really take a ton. The other fun thing that I can do is I can render this, so I can display the plans. I'm going to skip that because I don't have a ton of time. And I'm just going to, let's see, I can, for example, ask for different time granularities. So here I'm asking for metric time by week, or transactions by week. And then lastly, I can do this big query, which is basically going to show me that I can order. It is has a start time and end time, and it's got a few different metrics. So I'm getting transactions USD, transactions USD last 7 days, and I'm splitting all of that by customer, country, region. So I'm actually doing a multi-hop join. I have a cumulative metric. So there's a lot of kind of complicated stuff here, where otherwise I'd be writing a big chunk of SQL in order to get this table. And what that's going to do is it's going to build the SQL to do that, and then it's going to return those results. And that's really nice. But I actually want to see what's happening. And so I can do this thing where I say display the plans. What did I do wrong? Oh, I copied too much. We're going to go up. So I can make sure that I do that right. So I can say display the plans, and Metricflow will actually just render kind of the various nodes that it's going out and building this SQL query. And so you can see it's pulling from, they're a little small, but customers, countries, and transactions, those 3 data sources that I have. And then it's building the various metrics and dimensions. And then it's ultimately going to kind of perform this final operation of ordering it and then returning it to me. And so this is kind of what an analyst does in their head when they get asked the question of, hey, can you just really quickly get me transactions in North America, and transactions in North America for the last 7 days? That's like what our brains look like. All right, so I'm going to get back to this. So that's kind of a high level of what Metricflow does. And so that is a foundational chunk of what a semantic layer could be. And go back to, all right, how are we doing on time? We've got a few minutes. So if you think about the design of semantic layers, this is the thing that I've been nerding out about for most of the last 10 years. And I love talking about this, so if anyone wants to talk to me about this, I would love that. Feel free to come up to me after. And so semantics are basically what are the abstractions that you would like to define in order to go and kind of render SQL. And this determines what you can actually go and do with your semantic layer. On the other end of this, there are interfaces. And what I showed was a command line interface. And that is obviously not the most ideal interface for our business users to interact with. But if you can kind of connect that to your business intelligence, if you can connect that to Python or R where you're doing analysis, or if you just want to go and kind of build these tables programmatically, those are all interesting things you can do. And the interfaces really range on different semantic layers. So for anyone who's ever used kind of Looker or Power BI, these are tools that have semantic layers built in to a kind of custom interface that's built around that. But a lot of what I'm talking about right now is actually universal semantic layers. So semantic layers that are meant to interact with many different tools. And so once you have the input, the semantics, and the output, the interfaces, you obviously have to do some stuff in between. And so what we kind of just covered was query construction. Metricflow optimizes for performance, legibility. I missed the most important one, which I didn't even put here because it should be so obvious, but getting it right. And then performance, legibility, and kind of ease of manipulation. You need some kind of environment to go and execute that on. And a lot of semantic layers in the past have kind of rolled out with OLAP cubes kind of built in or something along these lines where you're expected to take your data warehouse and replicate some data into them in order to make them really fast. And I think that more and more, as cloud data warehouses are getting so efficient at doing joins and aggregations and actually serving BI tools in a fairly fast way, a lot of semantic layers today are just being built directly on the data warehouse, which is kind of what you saw in that Metricflow demo. And so step 2 is take your semantics, take your request for a query, build some logic, write it down to a data warehouse, and then return those results to an interface. And so there are a bunch of kind of interesting design decisions that can go into this. And the last piece is around governance. So the really interesting thing about metrics is that they're both the input and kind of the output of a lot of these kind of technical processes. And so you actually need to think about both the logic of the metric, but also some kind of important organizational governance components, like what is the tier of this metric, who owns this, what is it connected to, what's important metadata that you might want to be tracking around it. It's actually a really interesting place to do things like access controls, where row-level access controls for anyone who's ever worked on it. And I worked on this a little bit around Airbnb's, before Airbnb's IPO. It is so brutal. It's a very, very difficult task. And so a lot of what we kind of worked on at Airbnb was actually limiting access to the data warehouse and instead just giving people access to metrics, which just makes it a lot easier because you have kind of fewer end stakeholders who need to have access controls managed. And then the last piece that's really important for governance is just metadata. There's like a lot of interesting information in this diagram that you can track. Who is querying for metrics? Where are they querying from? What are they querying? How performant are these things? Like, how long are people waiting in their BI tools? There's a lot of information that you otherwise might not be collecting that's really interesting for the kind of administrators of data platforms. So I have two slides. One is on the benefits of semantic layers, and the next one is on the challenges. And the one thing that I really believe is that oftentimes all of the best parts of a tool are also the worst parts, and it's probably true for all of us also. All of our best parts are also sometimes our worst parts. And so just to kind of start with some of these benefits, obviously there's the single source of truth, right? You're moving a bunch of logic into one consolidated place. You're potentially making a nicer interface for people to consume from. So, I think business users find tables and joins and a lot of the things that are exposed to them a bit overwhelming. But if you can just talk about what you want in terms of metrics and dimensions, you can create much cleaner interfaces. And so I think if you look at the best self-serve BI tools, they all tend to have semantic layers behind them. The next one is just this ability that I kind of talked about of programmatically generating some of your wide denormalized tables. That is something that takes a huge amount of effort to go and actually build and kind of maintain the logic. And the reason it takes so much effort is because you're duplicating a lot of logic in order to construct those, right? You're writing the same joins over and over again. You're writing the same aggregations. And so a lot of that kind of non-dry, don't repeat yourself code can be consolidated into a semantic layer. And then the last one is governance, which I talked a little bit about kind of ownership and access controls. So now the challenges. And this is kind of where the rubber hits the road. Like, this is the reality. Not every tool can connect to a semantic layer. And so the reality is you're not going to get a single source of truth yet. This will take kind of more willingness for downstream applications to adopt semantic layers as a potential input. A lot of tools take a JDBC, and semantic layers are today getting pretty good at exposing JDBCs, database connections, directly to those tools. But a lot of tools kind of have their own custom interfaces. And there typically needs to be this kind of shim between a tool that wants a table and a tool that wants to expose a metric. The next really big one is that semantic layers are really good at querying known objects, but whenever there's something new, it's just easier to write a query, right? Because it doesn't exist in the semantic layer yet. The next really big one is performance. If you're not going to denormalize your data sets ahead of time, your BI users are going to kind of have to wait for a join to happen on the back end, right? And that's just slow. And that's oftentimes the reason why we do a lot of this kind of joining ahead of time. I think there are solutions to some of these, specifically for performance. You can make your queries more optimized, which is obviously one of the core challenges of metric flow is kind of rejiggering all of those nodes to try and make the queries more efficient. But you can also do caching, which makes performance potentially a lot better than even denormalized tables. The last one is maintenance. So if you're going to express all of this logic in one place, you're going to need to maintain it in that one place. And that takes a lot of buy-in from the variety of people inside of your organization who will be responsible for maintaining all of that code. And this is also true regardless. If you're going to define all of your logic in downstream BI tools, you will also need to have buy-in for maintaining all of that code. But it's specifically a challenge to do it in this kind of centralized way. And so I've talked a lot about semantic layers, but where do metrics kind of come into all of this? So metrics have historically been not kind of a core abstraction of a semantic layer. And if you look at a lot of the new semantic layers that are being built today, metrics are the core abstraction. And there are a few reasons for that. One is that metrics are one of the longest lived assets in a company. And this one is really interesting to think about. When I joined Airbnb in 2014, the company had been tracking nights booked as its kind of key North Star metric for a number of years before that. And still to this day, that is one of the most important metrics that Airbnb reports out to the market. But obviously, there's not a lot of information on some of these key metrics in most companies. They just kind of exist, and then various kind of important pieces of information, artifacts, are created, but they're not directly tied to those metrics. Everyone knows about metrics, right? Like when you get a request from a business stakeholder, you are almost definitely going to hear that request in some form of metrics and dimensions. And if you want to kind of try and think about this the next time somebody asks you for some data, I would encourage that, because it's just once you start listening for it, you'll hear it everywhere, that is how people are thinking about data. And then the last one is that metrics are really kind of at the center of everything. When you go and you make dashboards and you get data requests and you kind of are justifying some new business direction, like metrics are at the center of all of these different things. And so the idea is that by kind of layering metrics onto semantic layers, we can enable much better consumption. And these are, kind of screenshots of Transform's product of, the bets that we're making. So one of the biggest ones is being able to actually record annotations tied to a metric over time. I don't know how many times I answered the question at Airbnb of like, what happened on, I think it was March 3rd. It's good, I've almost forgotten. March 3rd of like April 2015. And it was a huge product launch, and all of our numbers went wild, and they were wild for weeks after that. But by 2017, everyone had forgotten what happened. And so the idea is that you can actually record this information in one place and then retain it over time. And then this, second one, like you can create better interfaces to data in new places where people actually work. And so the ones that I'm most excited about, G Sheets and Excel are, somebody asked me a few weeks ago, like, what's my favorite BI tool? And it's G Sheets and Excel, because it's just the place where you can go and you can do anything, right? And it's so easy to work with, and everyone knows how to use it. And so this idea of, well, what if I could actually form queries against the data warehouse and ask for metrics and dimensions from Google Sheets? It's pretty incredible once you give that to somebody who's natively working, like they're working in G Sheets anyways, and their current process is to get a SQL query that you have handed them months ago, run that SQL query, copy a CSV into the table, and then go and do the same analysis that they've been doing. If you can just replace that all with like a direct connection to the warehouse, you remove a ton of potential for error. And then the last one is just a bunch of this kind of organizational information. Things like, what's the definition of the metric? What is the lineage within, we have a direct integration with dbt, so what's the lineage that tracks down into the kind of like dbt pipelines that lead to this metric? So what are all the dependencies? And a bunch of other interesting stuff there. So I'm out of time, and luckily this is my last slide. So going back to my initial point, I think that everyone is analytical. They just need data and context. And if you can give them that data and context, then they can have the right numbers to actually do analysis safely. And you can tell by the kinds of things that people say that this evolution is possible, and that this kind of next generation of semantic layers is going to make it much easier for everyone to be able to participate. Which I just, as somebody who's been on the other side of answering all of these questions, there's something really powerful about empowering other people to be able to ask the questions that they have and that they know that they want to ask. but that they just fundamentally can't ask without your help, right? So thank you. Bunch of contact information for me, and yeah, would love to chat with anyone.
Thank you so much, Nick. How do you feel?
Great.
Good. Ready for a few questions?
Love that, yeah.
We got quite a few of them here for you. Let's start with the top one. Which underlying data warehouses are supported?
Okay, so right now in MetricFlow, so everything in MetricFlow is this open source project, and it's kind of the foundation for everything that we're building at Transform. And so whenever we add a new data warehouse to MetricFlow, that kind of carries through to other applications that are kind of built on top of MetricFlow. The ones that are supported right now are Snowflake, Redshift, BigQuery, Databricks, Postgres, MySQL, DuckDB. I think that's it.
That's a good list.
And it's actually one of the really interesting things is it's very easy to add new data warehouses to MetricFlow. We added Databricks in 2 days last week. And so it's very easy to add new data warehouses.
Awesome. How does it handle changes in underlying tables and data warehouses?
Yeah, so I mentioned caching, and if you're going to have caching, you need to know when things change, right? So one of the settings in the sample files is this specification of mutability. So like, how is the underlying data set that I am depending on changing? And the direction that we're going here, I think, is better than where we started, so I'll talk a little bit more about that direction. You basically just write a query which expresses when the underlying table has changed. So it could be as simple as like select max created at timestamp, and that is kind of when this table has changed. Or it could be more complicated, and it could be like a count of how many rows are in the table, or kind of a few different operations, and like a hash of those. And so what that'll allow is basically just like knowing the exact moment when something changes, rather than kind of knowing roughly when it's changing.
Okay.
Yeah.
Our next question. Why do you need query optimization in MetricFlow? Can't you rely on the underlying optimizations done anyways at the data warehouse level?
I would push that question back to the asker, like when you write SQL, can you rely on the underlying optimizations? The answer is data warehouses, as much as they try, they're just like these query optimizations are not very efficient. And you can just tell by the types of queries that everyone here, I'm sure, who writes SQL has written a query and then realized that they need to go from this join type to this join type, or they shouldn't be joining these two tables. They should first join these two tables and then join these two tables. And so that kind of decision of which nodes go first on that diagram is really important. But yes, once you render an optimal query, and MetricFlow's queries are getting pretty close to like perfectly optimal for what people are asking for, then you can rely on the underlying data warehouse to do a lot of the heavy lifting.
Great. How is MetricFlow related to dbt?
That's a good question, because I posted an issue literally yesterday, which kind of outlines our plan for the future of how these two things are tied. So right now, there is already an integration where your dbt pipelines and the lineage that comes from those pipelines can be directly tied to kind of the inputs, those data sources that are getting put into Transform. But the next generation of this is, so dbt has this new metrics tooling that's coming out, and it allows people to express their metrics directly in dbt. And so the way that MetricFlow will work on top of that is we will pull up those metrics defined in dbt and then do all of the same things that we do currently, which is building efficient queries, caching, hosting that, serving it, etc. So it's kind of, we're moving more kind of downstream of what dbt has today.
Okay, couple more.
Yeah.
How does MetricFlow integrate with existing data governance metadata solutions?
Yeah, so we so metric flow generates a bunch of interesting information, and that goes into logs that you can record. At that point, it's kind of up to you where you want to put those logs and what you want to do with them. But the Transform product on top of metric flow has a GraphQL API that serves all of the metadata that exists within Transform to governance metadata tools, so data catalogs, BI tools, et cetera, wherever you want to kind of consume them. Yeah.
Great. How does it handle inconsistencies and data quality issues in the underlying data, for example, inconsistent dimension values?
Yeah, so Metricflow is really good at doing denormalization, which is the kind of process of doing aggregations, filters, joins, et cetera. Metricflow is not good at data cleansing, and that is something that we kind of encourage people to do in their underlying data modeling. And so Metricflow typically sits on top of data that has been kind of cleaned and manipulated and is ready for downstream consumption. Yeah.
You mentioned that Metricflow doesn't work well with denormalized data sets. Can you elaborate on that? Yeah,
so it does work, but for the same reason why you wouldn't want to put a bunch of messy data into your semantic layer, putting a bunch of kind of denormalized wide tables limits what can come out of it, because you kind of need the ability to do joins in order to take any metric and combine it with any dimension. And so if you do that work ahead of time and you go and you kind of handle all of these joins on your own, then you're most likely getting rid of a lot of the identifiers and a lot of the granularity of the data. And so downstream applications will then not be able to use kind of any more granular information than what you're feeding it. And so doing a lot of this pre-joining is just going to limit kind of the joins that Metricflow can handle for you, and therefore limits, which metrics you can combine with which dimensions. But we work with companies that just build these huge wide tables and then expose that as an interface, and all Metricflow does then is it handles group bys and it handles filters. And it's just kind of, aggregating those tables up.
You're really knocking these questions down here, Nick. A couple more. Do we have integration with Spark?
We did have an integration with Spark before we open sourced. It didn't make it in kind of when we were refactoring a lot of our work to put it out into open source. It didn't make it. But these data warehouse integrations typically are fairly easy to build. So, I mentioned Databricks, which is Spark SQL, took about 2 days last week. Spark is a little more complicated, and it would probably take a little bit longer, but we don't currently.
Okay.
Something to build. You can go open an issue in Metricflow.
What are the top 3 future development areas of Metricflow?
Yeah, so the biggest one is completeness. We need every metric type in Metricflow for it to be really successful. And so we've been having this interesting conversation with some folks in the open source community around conversion metrics recently. That is one that I'm really excited about. I think another one that I'm really excited about is a little more flexibility in the way that we build queries. So doing things like, and this I'm just going to bucket into one, but just doing things like cross joins, being able to do CTEs, which kind of allows you to render more efficient SQL, just a few other kind of things that allow us to generate cleaner, more legible SQL. And then, what's the last one? I'm really excited about percentile metrics, because I don't know, I just tracked so many different things where I wanted P95, P99, and those are fairly hard to build. So yeah.
All right. The last question is up to you to choose.
I kind of already answered the DBT metrics one. And I think can a metric be defined once for multiple data warehouses? Yes, and that's one of the really cool things about Metricflow. It can render SQL to any data warehouse. So you can define a metric once and actually render SQL against different warehouses. And so you could actually have a data warehouse, define all of your metrics, and then decide, I'm actually going to switch data warehouses, and your entire kind of consumption interface can be moved over in like one fell swoop, which is, yeah, pretty exciting.
Thank you, Nick.
Yeah.
Big round of applause for Nick, everybody.